In this video, we're going to find the interval of convergence for the following power series. So what we do is we apply the ratio test, and as a reminder, the ratio test is we're using k as a subscript in this one, a sub k plus 1 over a sub k. But typically what I do, so I used k, so let's put a k there. Instead of doing a sub k plus 1 over a sub k, I'll do a sub k plus 1, so x minus 1 to the k plus 1 over 3 times k plus 1. Putting that k plus 1 in parentheses is important because a lot of times what I'll see is people will write it as just 3k plus 1 with, at the end. That 3 needs to be distributed. And I'm just going to multiply by 1 over a sub k, or the reciprocal of a sub k, which is 3k over x minus 1 to the k. We have our limit set up. The rest is just doing some simplification and some algebra. So we have the limit as k goes to infinity of the absolute value. Now we're going to use the property of exponents here. This is going to become x minus 1 to the k times x minus 1. All right, this is just a property of exponents. And we have a 3k here, all over 3k plus 3, let's put that in parentheses, times x minus 1 to the k. And now we look for anything that'll cancel. These two terms will cancel. And what I see now is this term no longer depends on k. So I'm going to pull that out. And when I do need to maintain the absolute value. So I get the absolute value of x minus 1. And now the rest does. Limit as k goes to infinity. And I do not need the absolute value on this part because it's all positive values. 3k over 3k plus 3. At this point, you're probably pretty comfortable with this limit. But if you're not, you could do around a L'Hopital's rule. This limit goes to 1. So we get the absolute value of x minus 1 is less than 1. Now, if all we're looking for is the radius of convergence, we have it already. It's equal to 1. But we were asked to find the interval of convergence. So we have negative 1 is less than x minus 1 is less than 1. And we'll add 1 to all three parts. So we'll get x has to be in between 0 and 2. Now comes the very important part that we need to do for the interval of convergence that we didn't need to do for the radius, which is always half of your interval anyways, is we have to test the endpoints, which means we have to take each of these endpoints, plug them into the original, and see if that series converges or not. You plug them in for x. So the first one is going to be x equals 0, which will give us the series from k equals 1 to infinity of 0 minus 1, so negative 1 to the k over 3k. I'm not going to go through all the steps, but this is convergent by the alternating series test. Next one we're going to test is for x equals 2. So we have k equals 1 to infinity. We're plugging 2 in for x here. 2 minus 1 is 1. So I have 1 to the k over 3k. 1 to the k is just 1. So I have k equals 1 to infinity of 1 over 3k. Well, this is 1/3 times our harmonic series. So this is divergent. You could either say by p series, or you could say because it's the harmonic series. It's a very famous series. So that means we do want to include 0 in our interval, but do not include 2. So our interval of convergence is going to be 0 to 2 for this particular series. Let's put this up here. Is 0 to 2, including 0 and not including 2.